Okay, guys, just looking at how a catalyst has the effect on kinetic energy distribution. So remember from earlier on in our rates notes, a catalyst is a substance that speeds up the rate of reaction, provide an alternate pathway. And therefore, the pathway that it creates will have a lower activation energy. This allows the reactants, the radicals, to react much easily and increases the rate of reaction. So we're looking at this potential kinetic energy distribution curve below. Remember from earlier on in the note, you noticed that this curve represents the number of particles with a certain amount of energy. The ones further to the right on the chart, the higher the energy, and on the y-axis, the number of molecules. When we take a look at this particular graph here, we can see that our activation energy, the energy required for this reaction to occur, is indicated here by the shaded parts. Only these number of molecules have enough energy to actually make the reaction occur. So this is what we would call, in this case, our uncatalyzed reaction. But what happens with when we add the catalyst is that amount of energy actually decreases. So the energy required for the particles to react decreases. So the activation energy, the amount of energy required, decreases. So there becomes our new activation energy for our catalyzed reaction. What we see is we notice now when we do that is we get even more particles have the required energy to go through. So our activation energy, our EA, is lowered. We need less energy, which allows more particles to react together. So as they collide, more collisions are successful. More particles have the required amount of energy to propagate. So again, this shaded area, when we look at these KE graphs, remember it's always the shaded area that represents the particles with the required energy. So without the catalyst, there was only the certain percentage, the originally shaded part. When we add a catalyst, the pathway changes and the amount of energy required when the particles collide to react with each other becomes less. Less energy required, therefore more particles now have the new lower requirement energy, and therefore they react, and our reaction occurs much quickly. I hope that helps to make sense of this part of the notes, and as you continue on through and work through the practice.